Hey everyone, welcome in. We're just going to give it another couple minutes or so just to let some folks join before we kick things off. All right, for everyone that's joining in, again, welcome in. We're going to go ahead and just wait about another minute before we get things kicking off. So while you're settling in, just a few quick housekeeping notes. All lines are going to be muted today since we are recording this session. And the good news is that because this is going to be recorded and this will be shared with everyone that's attending and registered. So this will also be posted on the Splunk Community Tech Talk page afterwards. So if you need to step away for a minute or if you need to revisit something later, you'll have access to this recording. So please drop your questions into the Q&A panel. And at any point during the session, we'll address as many as we can. We're going to take care of the majority of them live. We're going to save some of them for the end. And also we'll follow up at the end afterwards if there's anything that we didn't get to. If you're running into any kind of audio or video issues, the slide on your screen actually has a few quick fixes. You can start by either clearing your browser cache. You can start by maybe switching to incognito mode, trying a different browser. If you're on a VPN, sometimes getting off of that usually does the trick. So I'll give you guys about another 30 seconds just to take a look at that if you guys need to get any of those issues addressed. Okay. Let's go ahead and get started. So, welcome to Observability Simplified, combining user experience, application performance, and network behavior. So this is actually the second session in our 3-part network observability series. For some just quick context, for the ones that might have missed the very first session a couple weeks ago, we kicked off this series with a high-level look at how Splunk Observability Cloud and Cisco ThousandEyes can come together to give you a unified view across the applications, infrastructure, and network. Today, we're going to go one layer deeper than that. We're going to talk about how those insights actually surface across the stack, bringing together what your users are experiencing, how your applications are performing, and what the network is doing into a single usable view. And then on June 9th, we're going to close out this series with a hands-on workshop where you'll actually get to roll up your sleeves and actually integrate ThousandEyes with Splunk Observability Cloud yourself. So today's session is more so the bridge between the why and the how. Our goal is that by the end of the next hour, you're going to walk away with a clear picture of how to stop guessing whether an issue is in the application, the infrastructure, or the network, and instead you're just going to know. Just for some quick introductions, my name is Samara Remawi, and I'm joined by Vinod Vidir. We're both solutions engineers here at Splunk, focused on observability. We spend our days working with SRE teams, platform engineering groups, incident response teams. Our goal is just to really help everybody get to root cause faster and reduce the time that their teams are spending in these war rooms. So here's the roadmap for what we're going to do over the course of the next hour. First, we're going to talk about a problem that I think everybody in this call probably has felt, and that is the struggle of siloed troubleshooting. That moment in a war room when absolutely nobody can agree what's going on. Second, we're going to walk through how the combined Splunk and ThousandEyes approach changes that conversation entirely, giving you visibility from the user through the application, all the way out to the networks that you don't even own. And then third, we're going to have Vinod get into a live demo, and he'll show you what this actually looks like in practice, how you can pinpoint a network issue impacting application performance in just a few clicks. And finally, we'll talk about what's next, how to keep this journey going, including the workshop that's coming up on June 9th. So let's start with the problem. And I want you to think about your own environment as we walk through this. So looking at this slide over here, you can see that we have our own network teams using one set of tools. You have the middleware guys having their own dashboards. You got your logs that are being pulled from somewhere else entirely. The database team has their monitoring. Infrastructure has their very own. And then there's obviously the cloud, which often introduces a whole new set of tools that don't talk to anything else. So each of these teams is doing a great job of working on their own in their own lanes. But when something goes wrong, which it almost always does, what happens? Everyone jumps on in a war room call. Everybody starts pointing fingers at one another. Sometimes it's at 3 or 4 a.m. So that means you're maybe waking up a spouse or some kids. And this becomes a whole chaotic mess. So at this point in time, everybody's really trying to prove their innocence. It's not me. My stuff is green. And then you spend the next few hours, sometimes even days, just trying to hunt exactly what's going on. So the problem is that once everybody wants to come in and say that this isn't my problem because my dashboard is green, this is a silo troubleshooting approach. But disconnected tool chains essentially create blind spots, especially for problems that span across multiple different teams or services. And the harder truth is that most modern issues do span across multiple different teams. So like a slow checkout page might be a database issue, a CDN issue, a third-party API issue, or an ISP issue between your user and your application. But without that unified visibility, all you're doing here is just guessing. And the cost of that guessing is absolutely real. It's longer mean time to resolution. It's customer impact. It's burnout on your own on-call rotations. And at the end of the day, it's also lost trust, both internally between different teams and externally with your own customers. And as painful as that is, the finger pointing, the waking up at 3 or 4 a.m., waking up the kids or the spouse, the long war rooms, the guessing, there's actually a second problem that's layered on top of it all that makes things even worse. So this one over here keeps executives up at night. What you're seeing is this real world service topology. You've got business processes at the top, either that's login, process, payment, search, withdraw funds. And these are the things that your customers actually care about. These are the things that generate revenue. And underneath those business processes, you have the technical reality, which is your Apache servers, your Kafka queues, your Docker containers, public cloud, private cloud, and the networking tying it all together. Sometimes you have hundreds or even thousands of components. And here's the problem with that. When your monitoring tools are siloed, they show you the technical layer. So that means maybe your CPU level is high, your latency is up, a pod might be restarted, but they don't take that technical layer and connect it back to the business aspect of things. When something goes wrong, you can tell me a node is unhealthy, but you can't tell me what that actually means in reality. And that's exactly what the user in the corner in the bottom is asking. Are sales for gold tier members going up or down? That might be a question your CEO is asking. That might be a question of the head of digital is asking. And right now, in most environments, nobody in the war room can answer it in real time. So just think about what that means for a moment. So a network team sees a latency spike on a specific path, and that's great, but they don't see that that path is carrying payment transactions for your highest value customers. The application team sees an APM error, but they don't know if it's hitting the login flow for 10 people or the checkout flow for maybe 10,000. The business context is lost in the noise. And this matters because not every incident is created equal. Significant latency increase in an internal admin dashboard, that could definitely be annoying. but a significant latency increase on the payment flow for your gold tier customers during peak business hours. Now, that right there, that's a revenue event. So, without unified observability that ties technical signals to business outcomes, you're treating both incidents the same exact way and you're prioritizing the wrong things. Now, we've got two problems that are stocked on top of one another. The first one being that we have siloed tools, which means we can't quickly find out what went broke. And then two, even when we do figure it out, we can't tell the business that actually means. So that's the gap that we need to close. So the question that we want to answer today is, how do we get out of this pattern? And that answer starts with this concept of digital resilience. Digital resilience is really about one core question, and that's how do you keep your organization securely up and running in the face of any kind of disruption? Not just the ones that you plan for, but the ones that you can actually predict, that you can't predict, whether that's a fiber cut, a third-party SaaS outage, a sudden spike in traffic, a misconfigured deployment. At Cisco and Splunk, we believe that digital resilience is built on three pillars that work together. That's assurance, observability, and security. The assurance aspect of it is knowing that the network and the services your users depend on are working as expected, end to end, even across networks that you don't own. Observability is having that deep, real-time insights into your applications and your infrastructure. So when something does break down, you understand the why and not just the what. And then security is essentially making sure that everything you're doing is protected with threats that are surfaced and addressed quickly. For today's particular session, we're going to be mostly focusing on that intersection between assurance and observability. Because as painful as all of this might be, a lot of that finger pointing actually does happen with these first two. So what does the combined Cisco and Splunk story actually deliver? Two things that work together. On the assurance side, that's the ThousandEyes. You get end-to-end network visibility into both the networks you own and also the ones that you don't. The internet, your SaaS providers, your cloud providers, your ISPs, your ThousandEyes, all of that gives you visibility into it from the perspective of your actual users. And on the observability side of the house, the Splunk Observability Cloud, you get unified visibility across your applications and the infrastructure that supports them. Whether that's real user monitoring, distributed tracing, infrastructure metrics, logs, all of that being correlated together, which is the key word here, correlated together. And when you combine those two, what you get is context. And context is the thing that's been missing from a lot of these observability strategies. It's just not enough to know that the application is slow. You need to understand why it's slow and where in the stack that slowness is originating from. The other thing I just wanted to quickly call out here is, and this is a real differentiator for us here, is this built-in data and product integration across the broader Cisco portfolio, whether that be networking, security, collaboration, application, network, infrastructure, cloud. It's not a bunch of just acquired products that are all put together. We offer a true unified platform. And that matters for many reasons. And at the end of the day, every integration that you don't have to build for yourself is time that your team gets back. So let's get a little bit more concrete about how Splunk Observability and ThousandEyes work together. Think about the path that a typical user request takes today. Your user is sitting at home on their laptop, on their home Wi-Fi, and they interact with your application. That request travels through their ISP across the public internet, possibly through a CDN, into a cloud provider, through a facility maybe, into your application infrastructure, which then makes calls out to other ISP across the public internet, possibly through a CDN, into a cloud provider, so on and so forth. Now, Splunk Observability Cloud is incredible at telling you what exactly from the moment that request hits your application all the way through your infrastructure, whether that's real user monitoring, traces, metrics, logs, that full stack visibility on the things that you own and operate. But what about everything before that request actually hits your application? The user's ISP, the internet path, the cloud provider's edge, the SaaS dependency that your application calls on. That's where ThousandEyes comes in. ThousandEyes acts as that big data source for the parts of the journey that you don't control. And it feeds that visibility right alongside your Splunk data. And the results, that's essentially one continuous view from the user's experience through the network, whether it's owned or unknown, into your application and infrastructure, and back out to the service that you depend on. So now the idea is no more of a matter of is it us or is it them? You'll know exactly who it is. So let's make this real with a few common scenarios. I bet at least one of these has got to sound familiar to you guys. So for scenario one, you get a page. Users are complaining, something is broken, maybe checkout is slow, maybe the application is timing out for a subset of users. Your team jumps in, the application team comes on, they check their dashboards, everything looks okay. The infrastructure team checks theirs, everything looks good there. The network team starts to get pulled in, and now you're a couple hours into this incident and nobody can agree on what's actually wrong. So you might know what's broken, users can't check out, but you don't truly understand why they can't or what the underlying root cause is. And that lack of insight leads to prolonged outages, finger pointing, war rooms, significant delays in resolution. It's a headache. And really the idea here is how can you prevent that? You can leverage ThousandEyes to provide AI-driven root cause analysis across both your own and unknown networks, instead of guessing whether it's your firewall, your ISP, or maybe AWS just having a bad day. You'll get a clear answer within minutes. And that answer is backed by data with a visual path showing you exactly where the problem is. So the shift here starts going from reactive troubleshooting to proactive root cause identification. For scenario two, this is for all of you out here that's in the middle of a cloud migration, and that's probably the majority of us. You're essentially moving critical applications to the cloud. Maybe it's a lift and shift. Maybe it's a refactor. Either way, you're making significant changes to where your applications live and how they're delivered. This might make you nervous because once these applications are out in the cloud, you have a lot less direct control. You're now depending on internet paths, cloud provider availability, regional issues, and a whole lot of variables that just didn't exist when everything was in your data center. The fear might be, how do I ensure continuous performance and availability through this transition? The idea here is, with Splunk and ThousandEyes together, we can give you a baseline before that migration, visibility during the migration, and ongoing assurance after the migration. You can see exactly how user experience is changing as the workloads move. You can compare network performance from on-prem versus cloud. You can validate that your SLAs are being met from that user's perspective, not just inside your own, not from just inside your own data center. And that's how you make change-resistant, mission-critical applications a reality. Now for scenario three, this right here is one that we tend to hear the most often from leaders. You're constantly battling fires, outages, slowdowns, performance issues, weird in-a-minute problems that are showing up on a random Tuesday afternoon and are absolutely gone by Wednesday morning. So your teams are just exhausted by this point. And the worst part is you have no idea where these issues originate or how they're connected. Are these all the same root cause? Maybe they're unrelated and there is nothing altogether tying it together. And is this really getting worse, or is it that you're just maybe starting to notice it more? So the underlying problem is a lack of unified visibility across the entire digital ecosystem. Every team has their own view, their own metrics, and their own definition of healthy. Nobody has that holistic picture. What you can do here is leverage Cisco Observability. Splunk plus ThousandEyes as a single unified platform that bridges the gap between network, application, and infrastructure teams. One view, one source of truth, shared context across your different teams. So when an issue happens, you're not pulling people from 3 different directions into a war room trying to figure out what's going on. That puzzle already comes assembled and ready for you. One thing that I like to say is that seeing is believing. So let's go ahead and actually take you to see the product itself. And what I'm going to walk you through, or what Vinod is going to walk you through, is a real world scenario where we're seeing application performance degradation, and we need to figure out fast whether that problem is in the application, the infrastructure, or the network. So Vinod is going to start off in Splunk Observability Cloud and give you a real feel of how it is, from how things look like from the user's perspective. He's going to follow through a trail down through traces into the services, into the infrastructure, so you can see how quickly we can isolate where in the stack the problem is originating from. Okay, and now on to you, Vinod.
All right, can you guys hear me okay?
I can hear you, Vinod.
All right, perfect. Let me share my screen. So again, hi, my name is Vinod Vaidya. I'm an observability solution architect. I also work in the open telemetry space. And today I'm going to talk to you guys about Splunk Observability Cloud, which is built on top of OpenTelemetry. So what I mean by that is we are ingesting all the data with agents and collectors, all based on OpenTelemetry standards, based on OpenTelemetry agents. We have our own distribution, so we have support from Splunk and Cisco, and you're also not tied to a vendor-specific instrumentation or collectors, right? So that's kind of the high-level view of what the product does and how the product is built on top of the instrumentation and collection of the telemetry. So this is the homepage. So when you come to the homepage, you will see. So from a SRE perspective, you would see the things that an SRE would be paying attention to in terms of the alerts for the day, the live feed of alerts, dashboards, and so on. And here I'm actually going to start with, I won't go to the alerts. By the way, do I need to increase the font size? Is it too small? Should I? I'll increase it one more. So I'm going to, because there are some screens that are very busy. So I don't want to increase it too much that you will not see some of the things. So I have, so I'm from the homepage. Homepage gives you the SRE view, day in the life. They would come in and go from there. They might even come in from another notification system. So the dashboards are, you might have a link from an alert or a detector, and you might come in straight from there. So if you come to the APM page, APM stands for Application Performance Management. You would see the services that an SRE or a monitoring APM person who's not as familiar with the services or because they're not in, they're not the one who's responsible for the service itself, but they are responsible for making sure that the lights are on, right? Services are running, infrastructure is up and running. So they would come in and see, okay, these are the services that have errors, these are the error rates and ones that they should be paying attention to, right? And here I can see some of the services have, the health is critical, and we are going to jump into one of them so that way we can get deeper into that. So before I actually jump deeper into that, I want to also make sure we see there are a bunch of other things that we will look into. The service map, which kind of gives you view of the whole thing, but I'll get into that before. So you have a list of services that SRE would be paying attention to. You can look at it as a business transaction as well. It's a group of services based on the what is critical for the business. So in our case, we have some transactions that are based on, if there's some errors in when the customer is placing order on your website. that is critical, right? So you want to track those. So these are things that you can find out right from when you log in, right? So this is a page that I looked at because the checkout actually had some errors, and the errors, this tells me a subset of services that are involved in the checkout. So you have the front end. The user comes in from the front end and hits the checkout service, which in turn hits a whole bunch of other services. And we are seeing that there are some errors in these. We'll go deeper, but at the same time, this gives you all the information that you need for the checkout service, right? So I can look at the latencies and so on. So again, going back to what Samir was referring to, right? You are looking at this from individual service, but there is a lot of other services that are dependent. So what you get here is a distributed service map, right, which tells you what are all the components that are related. So and this is all in the context of one service, right? If I remove that, I'm going to see all the rest of the services coming from the front end all the way, to the yeah. This is the one that checkout, which we saw there was some critical errors. So the latency could be coming in from a service, from the connections between them, right? So here you can see, let me zoom in a little bit. These connectivities are the network connectivities between these services, and based on if there is some latency, as you can see, there are some latency here between the checkout service and the Kafka topic. And in this case, there is a checkout going into a payment service that goes to an external service. So I'm able to infer some of the external services. I am able to inject. So this map is completely built automatically based on the agents that I have deployed on these services. And in some cases, these agents are also collecting inferred service information or inferred database information. So I have, for instance, this fraud detection service goes through before checking out. You're making sure that there is no fraud. I'm hitting a database. So when I hit the database, I can see the latency. I see the queries. So if it's a query that's a bottleneck, I can come in. I can see if there is a certain query that is problematic, right? If it's locking a table, so I see I can quickly determine if I need to optimize a query. So the problems could be across a bunch of scenarios that we looked at, right? And the idea of having an open telemetry agent is to be able to collect instrumentation and correlate between them, because now you're sending the context header all the way from the front end to your backend service or backend messaging service or database service or Redis. So based on the component that I'm clicking, I will see different, like in this case I'm getting endpoint, so I'm hitting the endpoints. I can see the percentiles and so on, or I would see how they, like in this case I'm hitting a Redis, so I'll see the get and puts on the Redis. So this view actually changes based on the service or the component that I'm clicking on, right? So in this case, checkout is hitting a payment service that has some errors. So I see that there is a bunch of service request and latency, and I can drill down into one of them, one of these traces based on the duration that I. So this is a good way of going from a specific request, right? So you see the distributed service, and I can do it all the way from the front end to the back end across all these network hops. So this network hubs are determined based on the entire trace view. So if I see one of the I can actually maybe open up another window here. So let me show one of these payment service things. So I have a trace view which tells me how it went through a bunch of checkout service, place order service, get product. So I hit a code and finally I am going through a charge where I hit a service error, and it kept retrying, and finally it went through. So there was a this user actually had this user session came through the backend, and it hit a few errors in the payment. So it was a combination of a payment service error with the overall user getting delayed, right? Because the delay was because there was a bunch of errors. So I am able to see the entire component, and I can see how much time it took in every one of these components. And if I look at these error, I see the specifics of that span, right? So these are all the spans within a trace, and I see that this error is coming from this specific uh, component, and let me just make sure. Oops. So as you can see, I can hit either the infrastructure that it's running on, which is a container, or I can go to the exact log for the trace. So these are all the log entries for that specific trace ID. We looked at the waterfall view, right? And we see this is a container that this service is running on. This particular payment service. There's a lot of other services. They all have different containers. We'll get to that. But I want to first highlight the log piece, which is only for this one trace. And there's a bunch of other information, but I can easily group them by any of these attributes. So in this specific case, I'm going to just group them by severity, and with one click, I can see these are all the errors. So I'm going to just filter them by this severity of error, and now I see that the the payment processing was not the errors because of the invalid API token. So by a quick search, I mean, I didn't even have to search it. It actually took me to the right log entry based on the correlation. And this is something that I came in from the service map, from the alert, all the way. So there are different ways that you can actually do this. I can ask the AI assistant, which will list me the errors. It will tell me what are the things that I can look at. For now, I'm actually just going to focus on the distributed trace, because this explains, because now that we are familiar with this scenario a little bit, I can do different breakdowns based on these different attributes. So I could be, there could be different pods that are I can do filtering by those. I can do even custom attributes like tenant level. So if I have a customer profile where there are some silver, gold, bronze customers, I can see that this checkout service is actually hitting all the types of customers, right? So this blast radius is not just related to one type of customer. I also have ways of splitting them by version numbers. So I see the errors are all emanating from 350.10, not from 359. So this is another, uh, just by looking at the service map, you can quickly make a hypothesis that 350.10 is the one that is have an error, right? So you can ask your CI/CD or deployment team to revert back to the 359. Right? So these are quick ways of getting the root cause, because you have a distributed trace, right, across all your services and all the things in your network, right? So it's not, so typically an error could be coming from a user uh, front end. So I'm going to actually show you from that as well, that perspective. So we also have agents that are running on the front end, right? So I will let me actually show it to you on this one. So I have a user. So this is a front end application, online boutique with page views and page routes that based on so these are all the URLs or URIs or components on the page, and I can see that the checkout actually does take a lot longer. So I can drill down into the checkout. I see the web vitals, how each of the pages on my website is working, and if I hit the checkout, I get a tax spotlight view, which tells me how the documents are being loaded, where my customers are coming from, environments, how the browser versions are, which is a geolocation. So I can quickly see that folks coming from Denver have a high percentile. So I can easily, with one click, add to the filter, and I just get the viewers, the users from there, and I can even go further down and just look at a specific user session that had this high latency. So this poor user actually took a lot of time, right? This user took six seconds, and 6 seconds is an eternity in today's world to on a page, right? So in that 6 sessions, that user, the poor user, was waiting for 6 seconds, but most of the time is actually spent on the backend, 5.38 seconds. So the front end, the document load, it went through a homepage, they hit some products, and then they added it to the cart and checked out, right? And when they checked out, as you can see, this specific scenario, there's a bunch of the application took 64%. Database took some time. Network was fine here in this specific case. External service took a lot of time. This is the payment service that actually had some errors. But as you can see, this gives me a quick view of how the front end is correlated with the backend, right? So I can, in this case, hit the order ID of that specific user, or I can hit the checkout workflow, which will take me to the exact service that I need to pay attention, and then I can go through the same workflow. Or if I hit this from here, if I hit the trace ID, this will take me to the exact trace that we looked at, right? Entire trace view. Or if I click on the order ID, this is a custom attribute. This is something that we do not collect out of the box. This is if you want to. So this is we are not sampling anything, right? We're collecting every single user session that is coming in. So if you have a user, so you have a website, where the users are coming in from maybe the website, they might be coming from a mobile app, they might be on different network, some might be coming from Wi-Fi, some might be coming from a 5G network, they might be moving from 5G to LTS and so on. So these are all things that we are capturing and telling you that what is the cause of your user experience being poor, right? So that is that is how we are actually collecting. So going back to this page where we were looking at the tax spotlight view and the so there's a whole bunch of other views. Like you can look at each of the pages. You can look at every one of the network requests on your page. We can do the tax spotlight view. I can also do custom workflows, and this is again a capability that is now also integrated with ThousandEyes. As Samir was mentioning, we are also collecting how the users are coming in through various network providers and so on, right? So sometimes you might have some latency, not because uh, you know your website is doing fine, but it could be some last mile issues with their service provider. So we are tracking every one of those, and we have out of the box dashboards for some of these. I can actually show you, um, the dashboards that we have for ThousandEyes network monitoring. So it will tell you how your network is performing from a user perspective, right? How, if there is any network loss and so on. So this is uh, all coming as part of real user monitoring, and session that we are bringing in all the way from the distributed trace, which is initiated from the front end all the way to your back end, right? And all the network hops in between. So hopefully that gives you a good sense of taste of what is in the platform. There is a lot more we can talk about. I haven't actually showed you the all the log correlation that we were discussing. You can do this with Splunk Cloud, because our log correlation that I was showing you, this part from Splunk Observability Cloud, is actually coming from Splunk Cloud, right? So which is a analytics log analytics platform. So you can do all the this is like a SPL that is written for you, right? So I came in from Log Observer, from here. I can hit Splunk Cloud, and I can do the exact analysis. So I can see where the payment service is erroring out and so on. And similarly, there are the infrastructure correlation that I was referring to. We will get to that in a subsequent, but I will just give you a quick taste. This gives you view of how your Kubernetes network, Kubernetes CPUs, memory, all of that is performing, right? So I think we have, hopefully we have given you, for the amount of time that we have, a good taste of what is in the product. And yeah, let us know if you have any questions, and we can go deeper based on. Okay, perfect.
Okay. Thank you, Vinod, for that. Let's see. So before we get into Q&A, can you hear me, Vinod, by the way? Am I good?
Yeah.
Before we get into questions, just a few resources to just keep the momentum going. As you can see here, we have different documentations and different blogs that you can check out, get a little bit more information on the whole idea of the unified network observability. We got some ThousandEyes documentation showing you the integration between Splunk Observability Cloud and ThousandEyes, along with a little bit of a blog here to show you that whole end-to-end digital resilience concept. Feel free to check that out after that. After this is done, we will be sharing those links with you. And just over here, a few things to show you or plug you in before we wrap up. And as we can see here, you can sign up for our Splunk Community Office Hours. We have our Splunk Community Office Hours, where technical Splunk experts answer your questions and provide you live how-to guidance on various different topics. We have Splunk Answers, where you can search for Splunk Enterprise to view or share best practices. We got the Tech Talk discussion section, just to keep the conversations going from today, and ideas where you can vote on or maybe submit feature requests directly. So this is a great place to keep going and keep learning coming between our sessions. And now for the Q&A. So I'm going to go ahead and get started with some of the questions that had came into the chat earlier while you were doing the demo, Vinod. So Vinod, we have here our very first question. Where do the ThousandEyes agents need to be deployed in order to see the path between a microservice and a DB that the microservice is calling on? Does it need to be installed inside the microservice container that calls the DB, or also at the DB layer itself?
So, ThousandEyes agent can be deployed. There are lots of different options. Uh, you could deploy it as a container. You can deploy it as VM, bare metal. So you would have it alongside, wherever the device that you're trying to monitor, right? Now, the data that is coming from ThousandEyes is also an open telemetry format. So that's how we bring that into the observability platform and correlate it with the rest of the telemetry that we're collecting from services and infrastructure. So Kubernetes infrastructure, we didn't get too deep into that. APM services, the traces, and the network telemetry that is coming from ThousandEyes agent. They're all in the same format, same semantic conventions that OpenTelemetry has, and that's how we bring and stitch them all together and tell you how much time it takes between the services. So to answer your question, yes, the agents are deployed where your service or the devices.
Great, thank you. So, a follow-up question. So we got over here, is ThousandEyes only showing data from synthetic tests, or the case that you demoed, is it actually showing real-time data from all transactions? Can we see real-time network health data?
Yes, yes. So the ThousandEyes is real. Actually, even both real user monitoring and ThousandEyes and APM, right? They're all real time. And so Splunk Observability Platform is meant for streaming data, right? So as the data is generated from the source of data to hitting our backend, it's a mere few seconds, right? So you would typically see the traces. So a lot of times the distributed trace itself might take long to complete, right? To show all of that, because a lot of spans coming from different places. But as they keep hitting, you will see the distributed traces and network, you know, the time that it takes between each of the services, real time. Yes.
Great. Okay. And the last question that I already have ready in the Q&A is, in your demo, I see how OTel is helping us see latency of calls of underlying services, but I do not really see the ThousandEyes data inside the service map. So how do I
Yes.
know latency is a network issue versus an underlying services issue?
So that is a good question. So currently we have ThousandEyes integration that brings in the ThousandEyes data as dashboard. It doesn't show up. We have uh, some beta views. It's not in the existing product line. So the service map and all of that will also light up with the ThousandEyes data. Right now we have out of the box ThousandEyes integration, which brings in ThousandEyes data and shows up in dashboards. It's not in the service map dashboard, right, that I was showing you. So yeah, yes, that was a good catch. But it is coming. So yeah.
Perfect. So just keep an eye on that. Do we have any other questions? Anything else that we could help address? In the meantime, Vinod, do you have any other questions that you think that the audience might have maybe potentially could have asked? And is there anything that you have in mind that you would like to share in addition to what it is that we already spoke on?
Yeah. Yes. So network observability is a pretty interesting field in OpenTelemetry, and if you are following that space, there is a eBPF based instrumentation that actually brings in a lot of the network uh, telemetry as well. So this is at the level of containers on the Linux kernel level, right? So anything that hits a Linux kernel network, uh, we are able to collect spans. We're able to get the network observability, and so typically we all the agents are on the language runtimes, right, or on the infrastructure. So we have the open telemetry collector that is bringing in CPU, memory, disk, host metrics, and service metrics, and things that are more on the infrastructure layer and on the service layer. Now, eBPF is at the one layer below, right? So you have the, let's say if you have a Java application, you have the Java runtime running on top of Linux, right? So the Linux operating system itself has a lot of interactions that include the network request, right? So TCP, HTTP, all those. So any kind of protocol, um, network protocol, or service to service interactions that are not captured by the language agents, you can capture it from with eBPF. So there's a OTel eBPF instrumentation. It's called OBI. There's an agent that is available now, and that's also something that is upcoming. The Network Explorer piece, which will, along with the Kubernetes Explorer, will give you a view from the infrastructure to the network and show them in the same view. So that is something that is exciting from the Splunk observability and telemetry perspective, and that will also, along with the ThousandEyes and Catalyst, Meraki, all of those network telemetry that we're bringing in, and Cisco's Isovalent agent, right? The Tetragon agent, which is eBPF agent. That is what we harness for collecting all this eBPF telemetry. So this give you even more higher quality, high fidelity network observability, along with uh, the rest of the observability stack. So Splunk observability includes not just APM but also NPM, right? The network performance management with the Tetragon and IBPF agent.
Awesome. Great. Thank you, Vinod. And I see we got one last question that came in on the topic of agents that you were just, I think you're just talking about right now. So what is the difference between ThousandEyes cloud agents versus enterprise agents from visibility standpoint?
Uh, can you repeat that question?
Yeah, sure. So what is the difference between the ThousandEyes cloud agents versus enterprise agents from a visibility standpoint?
Okay, so and ThousandEyes has different versions of the agent, right? So there is you can deploy it in a different uh, based on the environment. You can so that is primarily the difference. So if you look at and ThousandEyes does things from the so there is a synthetic piece, there is a real user monitoring piece, there is a network piece, which is also like similar to what we were talking about in eBPF. It's looking at the protocol level, right? Uh, so so at the TCP UDP layer, it's looking at all those packets, and that's how it's bringing in the telemetry. So yeah, so there are different versions based on the environment that you're in. Yeah.
Great. I really do appreciate everyone for their time, and thank you for all the great questions. And thank you, Vinod, for answering them. So before we wrap up, though, the last thing I wanted to conclude with is that just some information here. So we got our upcoming tech talk and office hours coming up shortly. So if you want to inquire, you can scan these QR codes to register. We see, as we got listed over here, we have our office hours network to app observability unlocked on June 11th. We got our tech talk from network visibility to service intelligence on June 2nd. And I see here we have our office hours from network visibility to service intelligence on June 3rd as well. So bring your questions, bring your excitement. We'd love to continue to carry on here. And wanted to say thank you again for your time. And I see we have one last question that came right in. Vinod, are we good on time? Would you like to answer that question real quick?
Yeah.
Perfect.
Let's take the question. Yeah.
Awesome. So do you use the same ThousandEyes agent for both synthetics tests as well as for real user data? Or is it a different agent depending on what you need?
Yeah, so that real user monitoring agent is different from the synthetics monitoring, and so there is also, these are also getting consolidated because everything is going to be open telemetry based, and so I think I showed you the Splunk observability's real user monitoring, and I didn't really get into the synthetic space. So they are going to be coming in. It's you can deploy it as one. But synthetics agents are basically you're running scripts that are outside, right? Outside your website. So you're monitoring it from outside in, as opposed to the real user monitoring agent, which is deployed inside your website itself. So the agent is running. So real user monitoring is as your user is interacting in real time, right? You're collecting data. Whereas synthetic tests that are being run from outside, right? So this is not the real user. This is before maybe you launch your website, or as you have different versions of it, you want to make sure your website is running fine. All the latencies are. So you might have different locations, regions. So you want to test out all of that. That is where the synthetic tests come in. Right? So they are different agents in that respect. Yeah. You can use them along with synthetics and the real user monitoring agents work in tandem, because when you hit the website with your synthetic test and you have a RUM agent on that, you would collect the telemetry from RUM agent, and you would also have the synthetic test. So you can bring them together, right? But they are separate agents, yeah, or separate scripts and separate. One is an agent. RUM is more of an agent, and synthetics is more like a test harness, right? That you would use to test your website.
Awesome. Thank you, Vinod. And if there isn't any more last minute questions, I think we can go ahead and conclude the call and give you all a couple more minutes back to your schedule.